So, welcome to Feature Fridays. My name is Guy Bartram, and today I'm joined by Julian De Silva. Julian, why don't you go ahead and introduce yourself to everyone?
Hello, I'm Julian De Silva. I work in VMware's worldwide cloud practice. I'm a cloud solution architect, and my role is to help our service provider partners build cloud businesses.
Excellent. And today we're going to be talking about the Flex model. Flex model's been around for some time in VMware Cloud Director. It's an interesting, obviously very flexible way of dynamically changing resources and affecting existing reservation or allocation models. So I wanted to really talk through this because there has been, some confusion around what Flex is and how it works exactly and how it affects an existing allocation model or reservation model. So today, hopefully, we'll cover those details and get a practical example from yourself, Julian. So let's start by diving into Flex and what it is.
Yeah, so first of all, I must admit that the first time I saw Flex, I wasn't quite sure how it worked. I didn't understand, so I had to read through the documents a few times just to get a grips with it.
Yeah.
The whole idea is it does introduce more flexibility, so you're right, as the name implies, of course, in the way allocation of resources is handled by service providers, and crucially, more efficient allocation, more flexibility. So if you're working with vCloud Director already, you'll know we have three allocation models traditionally. Those are reservation, where you're effectively reserving a block of resource in your infrastructure, carving it out and handing it to a customer.
Mm-hmm.
Then you have the allocation model, which is a sort of halfway house where you're going to upfront reserve a portion of it, and that's down to you. It could be, say, 50%. And then you're going to offer the customer the ability to burst up to the rest of the allocation, because the assumption is you can potentially sell that other portion of resource you haven't committed up front, because chances are the customers aren't going to use all of their resource all the time.
Mm-hmm.
And then there's pay as you go, which is the simplest. We won't really talk about that today, which is a case of first come, first served to resources. Of course, you can set a limit, but the key point there is resources are not reserved up front.
Yeah, sure.
So if I may, I'd like to just share my screen.
Okay. That's great. I see your screen.
Excellent. Okay. What I'm going to do is I'm going to start in my lab. I'm just using a sort of hands-on lab style lab here because it works. It's good for me.
Yep.
And I'm going to show you a very simple example of how these allocation models are put together. So I have a customer called T1 here. I'll open up the portal.
And just
while that's loading,
everyone aware, these labs are hands-on labs are available to everyone, right?
exactly. So if you want to at home reproduce this for your own benefit to learn and play with the technology, sign up, log on, and start a lab.
Yeah.
I see I have 2 days remaining on this example.
That's a brilliant resource.
It is. So when we go to create new org VDC, so remember, these are the units of consumption for an end customer. A service provider creates an org VDC, a virtual data center for customers to deploy their workloads into. I'll just quickly show you the wizard interface of how we put it together. It's going to ask us, of course, which customer gets to own it. So I'm going to say T1 here. And then we've actually split the underlying infrastructure into two general tiers. I won't go into that in too much detail, but for this example, I'll use gold. And then we get to the crucial question: which allocation model do we use? So we can see a very simple explanation. I've already given you a brief explanation of how these work.
Mm-hmm.
And then if we look into, I'll take allocation pool first. So I've got some specifications here. So I can say my customer is going to get a total of 10 gigahertz of CPU. I'm going to reserve 20% of that. So committed 20%, burstable up to the rest of the 80%, and then similar for memory. So again, we've got the allocation of memory to the customer and then how much we're actually putting aside. I'll just cancel that and go back a step because I've actually got an allocation model example already. Instead, what I'm going to do is look at Flex. So when we go to create it, immediately you'll see there are different options available. So again, I want to do the same thing. I still want to give my customer 10 gigahertz of CPU, so I'll go ahead and do that. And I am going to set a CPU limit, and I'll explain how that works in a moment. Speed is 1 gigahertz, resources 20% reserved to CPU again. For memory, yes, I'll allocate that 1 gigabytes. I am going to reserve 50% in this case, and I'm going to choose unlimited VMs. It may be that you want to cap the number of workloads within a particular org VDC. In my case, I don't want to.
In this case, then it's
Finally,
exactly the same, but you now got the limits on there, which is the new piece of the UI that wasn't in the other allocation model.
Yes, exactly. So interestingly, this can work both ways. It can be unlimited if you want to.
Mm.
So just because a customer is demanding, let's say it's a particularly bursty workload and the customer is running some sort of batch run and they need that extra CPU, you don't necessarily, as a service provider, have to constrain them. Of course, they'll be aware they've exceeded their limit, and perhaps that's an opportunity for the service provider to charge an extra margin over the burstable capacity. That's a commercial decision. But you can enforce limits, you don't have to.
Sure.
Okay, now let's look at the important bit. Behind the scenes, Cloud Director drives automation. So I showed you this gold tier. All that is in reality is a resource pool built under my compute cluster. And I've set some priorities on that. But beneath, we have these resource pools. And again, these are created by Cloud Director. By creating an OVDC, these get built for you. So you saw me build Flex. So let me just track down my Flex example, which I actually called test. That's the one. Okay, so if I go to edit resource settings, this is what I have. So Cloud Director has gone ahead and said, I'm going to limit you to 10 gigahertz of CPU and 1 gigabyte of memory. Great. And I'm going to put an upfront reservation here of 50% and, of course, 20%. That's exactly what we want. Now, let me just go back briefly to Cloud Director and show you our VDCs. We have allocation here. Now, when I look at the allocation settings, I'll open this up for editing. Here's that form again. Those are the same specifications exactly. Now, bear that in mind. Precisely what I built in Flex. What happens when I look at it in vSphere? I don't have an upfront reservation, and I don't have a limit on memory. So just as a quick snapshot, let me pull up a slide deck for you and just show you what we built. So instantly, this is the first time you create the org VDC, one with the allocation model, one with Flex. This is what you see out of the box from the get-go. So we see that Flex is immediately reserving those resources up front. They are now committed. So 2000 megahertz cannot be used by any other customer in the platform. However, there is potentially the opportunity that if I'm a bit overzealous as a service provider and I want to overcommit left, right, and center, I can create 100 more OVDCs with this notional reservation of 20% CPU, but still at the SDDC level, we're not seeing it. And there is a reason why, and I'll show you very shortly. So let's switch back to the Cloud Director interface. And what I'm going to do is go into my allocation for VDC, and I'm going to deploy a new VM. So hopefully I have something in the catalog that's suitable. So I will call this alloc VM. Let's drop a simple machine in there. So this one here, and we'll call this VM1. Okay, and I'll just make that deploy. And I can see my Zoom controls are in the way, that's better. And create the VM. So what that's doing now is it's just looking at the resources in vSphere and it's seeing if it can actually go and create this.
In that case, that template is going to use one CPU and 256 mega RAM.
Exactly, nice and small.
Yeah.
So based on the allocation settings, we know that a CPU is clocked at 1000 megahertz because we've told it to do that. And we know we have enough memory in the reservation. So I think we had 1 gigabyte, so 256 should in theory allow for 4 VMs of the same size. Once it starts working, behind the scenes in vSphere, we'll see that VM being built. So I'll expand the source pool here. So I can see the original template. I can see another machine being built. So we'll just let that complete. And when Cloud Director is happy that it's finished, we'll look at the settings again. Okay, that VM is built. I'm going to power it on just so we can prove that the allocation is working. Okay, I think that's gone far enough. If I go back to vSphere, I can see the power on's completed. So there's my powered on VM. So let's take a look at this allocation again. So same resource pool for the allocation org VDC. Now this has been updated. So that's taken a reservation of 200 megahertz. So what's happening here is Cloud Director is actually updating the resource allocation settings as we commit workloads to Cloud Director. The same applies for memory here, 128, which is equivalent to 50%, as expected. Now let's take a look at the VM itself. So of course, on virtual machines, you can also specify resource settings. So if I expand memory and CPU, I don't see any limits or reservations. So what does this mean? It means in Cloud Director, in a traditional allocation model, when you allocate and reserve resources, that's done at the resource pool level exclusively. We're not touching the settings on the VMs themselves.
Right, that makes sense.
Okay, similar exercise. Let's do the same thing in Flex, which I called test in this case. And actually, this is an opportunity to show off another feature. I think what I'll do is while I'm in allocation, I'm just going to clone my VApp. It'll save me some clicks. Copy to. I'm going to call this Flex VApp now. And I'm going to send that to my Flex or VDC, which is test, and choose OK. Very handy if you're cloning a production application.
Yeah, totally. Especially if it's got multiple tiers of VMs in there and networks and all sorts of security between. That's nice.
Definitely. So I'm just waiting for that to build. And actually, again, if we look behind the scenes, we'll see that getting built. So test, expand that. Nearly there. I'm being a little impatient. I can see at the bottom, though, the VM is being created.
Yeah. So the behavior we expect to see here then is that the resources will be allocated to the reservation that was allowed within the Flex pool. Is that correct?
So what we're going to see here is, you'll remember when we first created the Flex OVDC, we had that upfront reservation committed in the resource pool. That's not going to change here because that's set aside now. What we are going to see is a more granular approach to resource allocation, and I'll illustrate that for you now. So the VM is nearly there. It's actually in a paused state, suspended, but that's fine. The settings will still apply. So again, let's look at the VM. Nothing here so far. So what we need to do is give vCloud Director a nudge. So once that's officially finished cloning the VApp, I'll power it on and we'll see what happens. So what we're waiting for is a lot of the back-end automation that Cloud Director gives you. So normally these are tasks that you'd have a vSphere administrator do for you. So you'd have someone go and create the resource pool and configure that. Then you'd have them clone the VMs, perhaps some templates, sometimes not. And then if there is any resource allocation to do at the VM level, you have to do that at the VM level. vCloud Director is doing that all for you now.
Can you change an existing resource pool to a Flex capability, let's call it?
I don't know. I don't know if there's a conversion.
Right.
I don't think so. Okay, that VApp's cloned. I'm now going to power it on. Powering on the VM is sufficient in this case. Switch back to the vSphere interface. Power on happens. And I don't know if you can see it, but down below there are some tasks. In addition to power on virtual machine, it's also updating configuration. So this is Cloud Director going in and modifying all the resource settings dynamically. So here we see those allocations are now set. So at the VM level specifically, I now have that portion of resource reserved and limit set. If I look again at the resource pool itself, that remains unchanged. That's a fixed entity now. So let's have a quick recap and see what we actually did there. So that was our starting point. And then at the next step, we came along, deployed a VM, and this is what changed. So imagine in our example here, we've got one VM with one CPU and 512 meg of RAM. The allocation resource pool was updated to reflect the reservation of the VM, the workload that was added to the org VDC. Down below, we can see the reservations set at the VM level, limits, reservations, nothing changed. Now, if we do the equivalent over in a Flex model, you can see that's updated dynamically. We saw that before. So the resource pool doesn't change. And immediately the benefit here is that service providers can plan their allocation and capacity much more easily. It's more, it's a fairer reflection of what's going on. So imagine a scenario where a customer has purchased an org VDC, they've bought an amount of resource, but they've not deployed any virtual machines yet. It's empty. From the service provider's point of view, looking at the metrics and stats, it's tempting to think that actually that customer isn't using the resource. So there's a danger, a small danger, but still possible, that a service provider could overcommit. So there are a few key points here. What we've seen so far is in the Flex model, resources are reserved at both the resource pool and the VM level. So this is where it becomes more granular. And when you're using the allocation model, resources are only reserved at the resource pool level. As we work with vCloud Direct and we deploy workloads, Cloud Director is updating the resource allocations dynamically. But resources are not reserved at the VM level, which means until a customer deploys a workload, we don't see that reservation in the SDDC.
But so in the allocation model, just so I'm clear on this, the customer cannot use more than the allocation. And in the Flex version of this, the reservation is applied on the VM.
Yes, so this is a fairer way of doing it. So you're right, when it comes to vCPU, even in the traditional allocation model, the customer gets a limit and that's set hard here. So what we're looking at here is the breakdown of what we've just seen. This is the allocation model. So you saw that wizard form of build in the org VDC on the left-hand side, and on the right-hand side, we see the end result at the resource pool level in vSphere. So let's have a quick look at those. CPU allocation is the easy one. So 10 gigahertz is immediately set as a 10 gigahertz limit on the resource pool. No problems there. Similarly, down below, memory allocation, well, that's a direct 50% reservation is applied. You'll notice in this case it's expandable. This means a customer can potentially exceed their memory allocation. Now, imagine that you don't do that and we untick this box expandable and we constrain the customer to using their memory. There's always a primary and secondary effect and consideration. So if you constrain memory in a vSphere platform or any virtualization platform for that matter, you're forcing paging where you go above those limits.
Yeah.
So remember, if you set a limit, you're forcing the hypervisor to prevent the consumption of physical memory in the host at all costs. So that forces paging. In other words, letting customers get close to breaching their memory limits is potentially risky and costly, because then your storage performance is hit as paging takes place. So we don't really want that to happen. For CPU, it doesn't matter, because for CPU, the only impact is on the customer themselves. And it's down to the customer to understand the resources they purchased and manage them appropriately.
Got it. That makes absolute sense. So Flex really gives you the control that you need, whilst also providing you the ability to limit, any effects on any other customers, for example.
Yes, exactly.
So this could,
and that's all being driven by vSphere, of course.
Yeah, sure. And how is Flex controlled via policy? Is there any way of defining different types of policies for different types of t-shirt sizing, perhaps?
Absolutely. I'll get onto that in a moment, because that's the really exciting part. In this section, I'll just quickly finish off. The last part we haven't talked about, of course, is reservations and how it's calculated. So in the traditional allocation model, we've said 20% CPU resource in this case, and a CPU speed of 1000 megahertz. So this is what happens. These reservations are calculated based on the percentage reservation, guaranteed resources, CPU, total vCPUs in the org VDC. So that's down to how many VMs the customer deploys and how many vCPUs they have, times the vCPU speed. So in this case, I've got 20%, and I've deployed, in this example, 4 VMs of 1 vCPU. So what you're seeing here is 800 megahertz is 20% of 4 CPUs at a 1 gigahertz speed. So that's how the allocation model is built. Let's compare that to Flex model. So again, we have our CPU limits. Now this is an interesting one. So the first benefit we're going to see straight away is CPU allocation is what you're going to give the customer. You're selling 10 gigahertz. CPU limit is your bursting. So if I choose unlimited, the customer can burst beyond 10 gigahertz and keep going until they consume the whole platform potentially. Not that we'll let that happen. Alternatively, I set a CPU limit, and the starting point is 10 gigahertz. In other words, the hard limit, the hard ceiling, is 10 gigahertz here. But what if I wanted the customer to have some flex? No pun intended. I'd say, okay, I'm going to let the customer burst to 12 gigahertz, so I'm going to give them an extra 2. So what I do is I set 12 gigahertz at CPU limit. If I do that, on the right-hand side in the resource pool, we'll then see 12,000 megahertz. Going down further, we see memory allocation is much the same. So this is a hard limit here. of how much the customer is entitled to. So again, 1 gigabyte set to 1024 megabytes on the resource pool. So that's good. We expect that. The reservation is a straightforward 50% of the overall allocation. Now, when we come to the VM itself, is remember the Flex model now sets resource allocation settings on the VM. There's another part to consider. So down below, right-hand side, this is an example virtual machine. So our CPU reservation on a machine is 20% of the total VM CPUs. So in this case, we have one CPU clocked at 1 gigahertz, therefore 20% of that is 200 megahertz. The speed is enforced, so we're actually doing something different here. Whereas in a typical cluster, you're going to have a native CPU speed in the host, and generally speaking, that will be reflected in the VM you deploy. But if you're selling specific megahertz, you can actually set that as a limit. So even if the host CPU is, say, 3 gigahertz, you can actually sell 1 gigahertz per VM core. And that's important because you can really break that down and sell very specific lumps of resource. And that is enforced at the VM level. That's not the case in the allocation model.
So that's a limit per core of the CPU, or the number of CPUs that you specify here, right?
So it's calculated on each core, if you like, each vCPU. The sum total of that. So if this had 2 CPUs in this VM, you'd see the doubling here. That's how it works. Because this vCPU speed on the Flex model configuration is per vCPU. So if we have 2 vCPUs, then the VM as a whole can handle 2 gigahertz of CPU.
Right, and it's getting pretty granular down to the megahertz level. I mean, that's pretty granular speed control.
It is, and there are benefits to that, and I'll show you the end picture of how this works in a moment. So very quick recap. Using the Flex model allows for a fairer distribution of resources across a customer's workloads within an org VDC. So go back to the allocation model. Remember, the only allocation constraints are set at the resource pool. In other words, the entire pot. So if a customer has a number of competing workloads in the same resource pool, some can win over the others. In other words, there's no way for the customer to really prioritize workloads. This can't happen in the traditional model. If that's important going forward, the Flex model is the way to go.
Yeah.
Now, as opposed to the allocation model, resources are committed upfront with Flex. So this is really important for capacity planning, as I mentioned before. Imagine a scenario again where a customer has purchased the org VDC, but for whatever reason, it lies dormant for a month, 2 months maybe. In other words, no workloads being created. When the service provider is looking at their allocation of resource in the SDDC, they can't see that upfront commitment because Cloud Director hasn't built it yet. But with Flex model, we make sure that doesn't happen. We reserve upfront before the customers even looked at the platform.
So what's the difference then, Julian, between, so I get this, so from a service provider's perspective, it makes much more sense to use a Flex model over an allocation model to gain, like you say, that granular control in capacity management. What is the difference between using a reservation and a Flex model then?
So a reservation is how much resource you're going to guarantee. Mm-hmm. It is ultimately found in the SDDC layer, so in vSphere. When you set a reservation, you're telling vSphere with a resource pool how much resource to set aside and reserve. The Flex model is exclusively a Cloud Director model. You're telling Cloud Director, how do I configure the underlying platform to allocate these resources fairly and properly and apply appropriate constraints. So all of this is realized in resource pools. The Flex model just gives you options as to how those resource pools are built.
Okay.
So here's a more deliberate example of how this actually works. So here is a comparison, allocation versus Flex. On this screen, we're currently seeing your typical allocation OVDC. And this customer has 2 OVDCs. Why? Because they have 2 very different types of workload, 2 very different characteristics. Mm-hmm. So on the left-hand side, your typical Wintel deployments, maybe there's a selection of applications in there. And the general policy for the provider in this case is reserve 20% CPU upfront. So that means they can resell the rest of it or stretch the platform a little bit further and get some more revenue. And 60% reservation on the memory. So the customer is paying for 128 gig of memory in this case. 60% of it is committed in the platform. 40% is either burstable or resellable, crucially. Now, this customer also has dedicated database workloads. For that, it needs a higher tier of service. So on the right-hand side, we have a dedicated database allocation or VDC. And in this case, as you'd expect, we're reserving everything up front. So the customer's paying for 10 gigahertz CPU, 64 gig of memory. It's completely carved out of the platform and can't be used anywhere else. So what this does is, from an architectural point of view, complicates things. So we have these database VMs, these workloads, and presumably they're going to have to communicate with the app layer. So that means we have to address this in the networking. So we have a couple of options here portrayed. We have going through edges, so your typical NSX-based scenario where you'll have an org VDC network and perhaps you'll route to the other org VDC. Notice you're touching two edges in this example. So now you're having to deploy another NSX edge to support this potentially. Yes, you could work around this limitation. You could stretch your org networks as well. That's also an option. So at the bottom of the picture, we've depicted that. But the key point here is the service provider is now having to create additional org VDCs to represent these different offerings. So what happens if we take these same requirements and then apply Flex? So straight away, we've just collapsed our org VDC structure. So what's changed? Now we can offer multiple compute levels of service within one org VDC. We can have different classifications of workload and we can treat them differently with one resource pool. Well, how can that be? Well, we know that in the Flex model, when we create an org VDC using Flex, we're actually setting things up at the resource pool level and the VM level. And that's important. So in this example, it's the same workloads again. And I have two policies in play here. So these are VDC compute policies. And very quickly, I'll just show you what that looks like. It's a little descriptor here, an example. And it basically says, okay, if you're going to request a 2 vCPU and 2 gig of RAM machine, in this case, I'm going to give you this specification, but crucially, I'm going to reserve a certain amount of memory, a certain amount of CPU in percentage terms, in this case, 50% and 50% in this example policy. That overrides the default policy of your org VDC. So imagine our default position, going back here. On the left-hand side, our vCPU speed is 1 gigahertz. And this is the default. When we created that for the first time, that's what we set. And we reserved 20% CPU, 60% memory. And then along comes this database policy, DB policy on the right-hand side. Actually, if a customer is deploying a database workload, I'm going to reserve everything. So what happens is the customer deploys their workload in Cloud Director, the VM gets built, it goes into that resource pool, and then the settings on the VM are overridden. So there's 100% reservation applied for CPU and memory at the VM level, and the CPU speed is increased, which means the limit is adjusted upwards to accommodate that. So we have two different service tiers within the same org VDC. That complicated network layout has gone away. Potentially the back-end complications from having multiple org VDCs from a billing and metrics perspective has also gone away. All we've done at the bottom is we've just increased the overall size of the org VDC to reflect the combined requirement, 20 gigahertz, 192 gig.
In your experience, Julian, is it would service providers sell the org VDC or would they sell the policies?
Well, this is quite new, but traditionally, service providers tend to sell org VDCs, the virtual data centers, and that's nice and easy because they're a unit of resource that you pay for. It's measurable, and then it's down to the customer generally how that's carved up. Going forward, there's a lot of scope here to have different tiers of service with policies. So you're in fact selling policies. So remember, traditionally you had this approach to things like gold, silver, bronze tier of compute. And either that came down to the amount of resource available or the priority. So in other words, let's say we had production workloads must always win in times of contention against dev test workloads. Well, before we'd have to achieve that with all VDCs separated, different structures. Now we can do it with policies. So these could be sellable units. Now the way they align to t-shirt sizes is effectively you build those t-shirt sizes in the policy. So rather than having a simple default policy versus DB policy, you build a series of policies with different specifications and crucially different resource allocations per t-shirt size, because in reality that's what we're looking at here.
So would you then create a so when you're creating the resource pool, I'm just trying to think of the when it's an allocation, you're allocating resource. When it's a reservation, reserving some of the resource in resource pool. When you create a resource pool using Flex, that could be, would that be something you would potentially offer to multiple customers, like a public cloud service with small, medium, large type tiers of VMs?
Yes, I think so. That makes a lot of sense. So you can make these bigger, simpler org VDC offerings and then have sub offerings within them, basically based on t-shirt sizes.
Yeah. And you'd have to use something like micro-segmentation to ensure that every VM is kept secure from every other VM, right?
Exactly. So combined with other features within the platform, you can group these workloads together. There was also, I'll just put this back, there was an option to add extra config values. So that's an opportunity to use things like backend orchestration to pull out characteristics. So the customer chooses a database server. So we know what the CPU and memory will be because it's defined in policy, must be this size. And then we can also see that because it's a database, it has certain security characteristics. So it can only talk to certain groups of machines. And the service provider or the customer themselves can create these policies in the back end under the security section in the portal.
And I take it this metadata is quite easy to get out from a metering and billing perspective, those key value pairs.
So it's at the moment it's all API based. I believe there is work being done to bring some of this into the UI. I don't know when that's going to happen, but certainly if you've got the design guide with you, the API guide, the information you need is there. And of course, we're here to help.
Yeah. No, it's brilliant. That makes absolute sense. And I think from a billing perspective and metering perspective, you're going to want it through the API in any case, because there'll be a whole load of data matching and lookups that you would need to do before you actually pass that through to your business support systems. That makes absolute sense. And, that clear example there of the one resource pool, sort of granularity of the resource pool versus, and the issues with having those different resource pools for those different workloads versus having flex policies. I'm kind of struggling, I must admit, to see when you would not want to use a flex policy.
Yes, I looked at this and looked again and realized actually this is a pretty good replacement for all the traditional models we have. It does simplify things, far more control, but it only really becomes apparent when you start to apply these problems in the real world. I mentioned earlier the key point that actually you get a fairer distribution of resources. There's nothing more frustrating as a customer when you come to your cloud portal, you deploy all your workloads, and then when you try to power some of them on, they don't come on because apparently you don't have the resources. But of course, up front, when you look in the portal, you think, I've got plenty of resource. I bought enough CPU and memory. Why won't this power on? And that kind of problem will probably reduce significantly. Because imagine within an org VDC, going back to the traditional model, you've basically got one pot of resource and one pot of reservation. If you've got workloads that are hungrily consuming it all, when you power on a VM, Cloud Director and the STDC does a check. Can I upfront reserve the resources in the resource pool when I power this on? If the answer is no, the VM doesn't power on, or because of the way the customer is using their workloads within the org VDC. Now, with this new model, going back here, because we're setting these reservations across the board, there's far less chance of that happening. So VMs will get those resources. Why? Because at the top level, the resources are being reserved up front. We didn't see that in the allocation model. So I think this makes for a better customer experience as well.
Yeah, totally. And I think you could use use that tagging, like the key value pairs, to track usage of the types of tiers that you're offering in terms of types of policies you're offering. But also, if you wanted to create a public cloud experience, you could do an unlimited resource pool with a ability to flex to not flex within the resource pool, the ability to go unlimited. But then within the flex policies, you can set those limits and reservations on. Which means essentially people can spin up. There's kind of two ways of doing it, isn't there? There's the way of letting people spin up whatever they want until all resources are depleted, which for a service provider then would imply a bit of capacity management, keeping an eye on how this org VDC is expanding, making sure there's enough resource to cope with that. Or there's the limiting per customer a resource pool, and then charging them, even though it's limited within the resource pool, but charging them for the policies that they're actually using. So I think it allows them to get much more granular with the traditional models of reservations, and actually from an SLA perspective as well, bring the SLA down from the resource pool to the VM, which is an interesting dynamic, because I know lots of service providers choose to do a reservation because it's just the way they've sold stuff traditionally.
Yes.
I.e., you want a 8 gig VM, Mr. Customer, I'm going to sell you an 8 gig VM even though you don't use 8 gig of it. and there's a missed opportunity there where excess resource in the platform that could be utilized for other customers and other services.
Exactly. And the reality is that most customers through the day are only using 20% of their CPU typically. There's a lot there you can resell.
Exactly. But I think it's an SLA conversation as well, right? Around the, well, what if he actually needs 8 gig? Will vSphere, because it's basically vSphere under the covers here that's doing all of the memory scheduling, will vSphere be able to cope with that given the demands on the platform at that time? And I think that's where, the reliance on having a SLA that is absolutely kind of guaranteed forces that reservation model to be used. Whereas there is another way of looking at this now, which I think is really important to consider for really getting the most out of your infrastructure investment.
Absolutely. And one thing I didn't show you very quickly is one to think about in the flex model, on the back of your point, is elasticity. If we switch that on, we can stretch and stretch and stretch. So we can keep adding to this pool of resource as we have to. So there's, again, a lot of flexibility here.
Excellent. All right. Well, listen, Gillian, thank you very much for your time today. It's been really useful. I certainly have learned a lot about the flex model, and I hope our viewers have as well. Thank you.
Thank you.